All right, thanks, Marcus. Well, I'll kick things off. I'll give a brief intro, if you like. Just let you know, I'm from the Bureau, as you said, and in the research program in the Bureau. Now, most of my research over the last 20 years has been focused on tropical climate, but I am living in Hobart, so that seems a bit odd, I realise, but it's where we are right now, and I love doing my work on tropical climate. And in fact, last month I was just up in the Gulf with a colleague, Chelsea Jarvis, who was planning to speak today, but she wasn't available and sends her apologies. So I'll kick things off then talking about the seasonal climate outlook, so for the next 15 to 20 minutes or so, and looking at the long-range forecasts, the latest information that just came out yesterday. Okay, so a bit of a road plan here. If you can hear me okay. So sea surface temperature is the first thing that we'll look at. Then I'll talk about the climate drivers. So we'll just kind of launch straight into the drivers. I know that's of key interest for you there. And then kind of taking a step back, having a look at how those drivers influence the rainfall and temperature outlooks for the next few months. I'll touch on the streamflow as well and the Northern Rainfall Onset before talking about some extreme outlooks as well for extreme weather conditions. So it's a nice place to start here, looking at the sea surface temperature, because on that seasonal timescale, it's mostly those ocean-driven climate drivers that tend to really give us those longer monthly to seasonal scale conditions that we look at in these seasonal outlooks. So here you can see, first of all, in the central to eastern Pacific Ocean, there's a box region here labeled Nino 3.4. So that is the region that we typically look at when we're looking at the development of El Nino and La Nina. So that pair of climate drivers is often known as the El Nino Southern Oscillation, or ENSO. So looking at the average SST, sea surface temperature, or SST, in that region helps us to determine the development of one of those ENSO events, El Nino or La Nina. And at the moment, you can see in the latest weekly anomalies, so this is just the past week, we see quite an elongated cold tongue here from the eastern Pacific into the central Pacific region, and so that indicates the La Nina condition that is currently active there in the Pacific. Then further west, around the Australian continent, particularly around the northern parts, you can see it's quite warm, and that's a typical pattern associated with a La Nina event, where it's cold in the Pacific and warmer than normal to the north of Australia. And that ties in with what's happening over the Indian Ocean as well. So over the Western Indian Ocean here, this is labeled the IODW box. So that's currently shows about kind of neutral, roughly neutral or zero anomaly. So a kind of average temperature for that region. But in the Eastern Indian Ocean, you can see it's warmer here than normal. So these are degrees Celsius greater than normal in pink, or cooler than normal in blue. So what you can see here is average temperatures in the west, above average temperatures in the east for the Indian Ocean. And that situation describes a negative Indian Ocean dipole. You've probably heard a bit about that. So often we do get a negative Indian Ocean dipole and a La Nina happening at the same time, and that's what's happening at the moment. Okay, so we'll go into the El Nino Southern Oscillation outlook. So as I mentioned, we do have an active La Nina event in the Pacific, and this is the wet phase of ENSO for Australia. And if we look at the models, so on the right here are each of the climate models that we survey at the Bureau. There are 7 of them, so these are from around the world. So the Bureau's one is up the top here. Then we have a model from Canada, from Europe, from Japan, France, and from the US, and then UKMO is the UK Met Office. So you can see at the moment, so the outlook for the month of November is showing fairly good agreement among the models, with almost all of them showing a continuation of the current La Nina into November. But then from December onwards, you can see some of those models starting to back off away from this La Nina threshold. So here where you see this blue region in the plot, that is the La Nina threshold, or where the La Nina threshold's exceeded. So you can see some of those models are still showing La Nina in December, but come January, many of those models are back into the white space in that plot, showing that we're looking at neutral ENSO conditions from fairly early in 2023. So this is looking to be a relatively short-lived La Nina event, so shorter lived than the last couple of years worth. But yeah, looking to end around the start of the new year. And as we know, La Nina typically increases the chance of above average rainfall for northern and eastern Australia during the spring and the summer months. So this is a little more information on La Nina. What happens during this event is that these easterly trade winds that flow near the surface across the Pacific Ocean, they become stronger, and we see warmer water piling up in the Western Pacific, just to the north of Australia. This produces more moisture in the air and more chance for increased rainfall and cloudiness, and that's what we've been seeing over the last few months. And in fact, over the last 3 summers now, this is the 3rd La Nina in a row, which doesn't happen too often. So we've had a run of La Nina events and wet conditions for eastern and northern Australia. What this also means is that there tend to be more tropical cyclones during La Nina events. There's more moisture, more energy in the system, tend to be more tropical cyclones in our region. And also we have an increased chance of flooding. And particularly because this is the 3rd La Nina in a row that we've had, we have very wet soils over the last, since the last event and the event before that. So we do have an increased chance of flooding and runoff. Moving on to the Indian Ocean Dipole. So the IOD in its negative phase is currently active. That has been active for a few months now. Around August, I think it was declared as a negative IOD. And what we're seeing in the models is that this is likely to persist through the spring, so into November, and then by December, the Indian Ocean Dipole here will be neutral, according to this model outlook from the Bureau. From all these models, so the Bureau model saying so, as are the other 4 models that we survey for this particular driver. So it's indicating, come the December period onwards, we're likely to have neutral Indian Ocean dipole conditions. This is typical. So each year when the Australian monsoon kicks in, the winds change from their easterly flow into more of a northwest, and they pretty much typical each year that we would see around December, January, the IOD return to neutral. You can see in this time series down the bottom here, we had a very strong positive Indian Ocean dipole in 2019. That was, of course, the year when we had heat wave and extreme fire conditions in Australia. And since then, we have been hovering around the neutral IOD index, but the last year and the last few months, as I said, we've had a negative Indian Ocean dipole. So it's been a fairly relatively strong negative IOD this year. And the impacts of that are typically increased chances of rainfall over southern and parts of eastern Australia and parts of western as well. So you can see here, this map on the far right shows the typical impacts for a negative IOD phase. So you can see there, generally blue represents wetter than normal conditions. Another thing to mention here, just in terms of the circulation here, you can see this large circulation, which represents again those westerly winds, this time over the Indian Ocean. And we tend to have a piling up of warmer water here just to the north of Australia. So you can see how often a La Nina and negative IOD go hand in hand, because both are conducive to this piling up of warm water to the north of Australia, again creating more atmospheric moisture and a higher likelihood of rainfall over those parts of Australia. The last climate driver I'll just touch on is the Madden-Julian Oscillation. Now, the MJO, I don't know how much you know about the MJO, but it is one of the key climate drivers for the tropics, and I've been looking at the MJO for 20 years. So I could talk a heck of a lot about this one, but I'll just touch on it today. So the Madden-Julian Oscillation is a much shorter timescale driver compared to ENSO and the IOD. So the MJO is characterized typically as an eastward moving pulse of cloud and rainfall near the equator, and it reoccurs about every month to 2 months. So what I'll do is quickly flick to the next slide and then come back to this one. So this is a little animation that I'd like to show. It just demonstrates the average cycle of the MJO. So you can see here, if we look at the Indian Ocean right now, this blue blob represents more rainfall that built up over the Indian Ocean around the Pacific. Now, we describe the MJO in terms of 8 phases that large convective rainfall system is sitting in any part of its life cycle around Australia, around the globe, and in reference to its position relative to Australia. So, for example, this right here just shows us cycling through those phases. So coming into phases 4 and 5, you see that rain falls to the North Australia. Phases 6 and 7 moves into the Western Pacific. Phases 8 and 1 for Northern Australia, that suppressed rainfall, and then back to phases 2 and 3, we see the rainfall developing over the Indian Ocean. So as I mentioned, this is an eastward moving tropical convective system that has a life cycle of about 1 to 2 months. So going back to the MJO forecast, the reason I wanted to talk about this is that at the moment, the MJO is forecast to be in those phases 6 and 7 over the next month. This plot on the left is what we look at to predict the MJO. So it shows a prediction of the MJO. It looks like a large plate of spaghetti in many respects, but the thing that's most, I guess, notable here is the black solid line, which shows our ensemble average forecast. So effectively, that's the key forecast that we're looking at, the black line, and it's showing the MJO for the next about 4 weeks to be cycling around phases 6 and 7. All of the other coloured lines represent the different ensemble members of the forecast that we run. We run the forecast about 100 times, and this is using a 33 forecast, this one, and then we look at the ensemble average, and that's the one in the black. And this grey line represents the last 2 weeks of tracking the MJO. So at the moment, we know that the MJO is strengthening just to the north of Australia, and it looks like it's moving into the Western Pacific region, phases 6 and 7. Down the bottom right here, these are the rainfall signals associated typically with MJO in these phases 6 and 7. And so these blues represent an increase in rainfall. And you can see for the Gulf and for large parts of eastern and northeastern Australia, we can see an increase in the likelihood of rainfall. So it's not just the La Nina and the negative IOD that are influencing rainfall, but for the next month at least, the MJO is looking to also influence rainfall over these regions. So that's an important climate driver for your region to look into and to learn a bit about. And just last month, I was in the Gulf with Chelsea, and we were talking a lot about the MJO because it really is one of your key drivers on that multi-week timescale. So moving into the outlooks, so these are the temperature and rainfall outlooks for the November to January period, so the 3 months. If we start with maximum temperature, you can see for large parts of Eastern Australia, we're looking at an increased chance of generally of below median daytime temperatures. So that's what these kind of blue regions represent, and then red is an increased chance of warmer than average daytime temperatures. So you can see for the Gulf and for much of Eastern Australia, we are expecting cooler than average conditions over this period. But minimum temperatures, so over temperatures are showing the opposite. And in fact, for most of the country, we are seeing an increase in the likelihood of warmer than average nights. So this relates to the rainfall forecast partly. So on the far right here, we're seeing the rainfall outlook is for a fairly high chance of above average rainfall, and particularly for the Gulf, you can see how that signal is distributed there across those regions. And so what we're actually seeing is not just this rainfall outlook, but also the warmer water around Australia that's also influencing the temperature outlooks. So for daytime temperatures, we are seeing this influence by more raininess, more cloudiness, and so that's generally tending to give us cooler days. But then the opposite is happening overnight with that extra cloud cover. We're seeing some of that warmth stay in. The cloud can act like a thermal blanket, but also warmer water around Australia, also bringing warmer airflow to the country in general. Now looking out a little further, so this is December to February, what we're seeing here for the Gulf is now kind of average to above average daytime temperatures generally, and overnight temperatures Australia-wide really are still showing a very high likelihood of above median overnight temperatures. And the rainfall signal again is showing for that period is showing above median rainfall totals. Again, largely, so those higher likelihoods really you can see over the Gulf and over those broader parts of the northeast. So that's what we're expecting looking forward. And now if we move into the extremes outlooks, so this is looking at the chance of unusually wet or unusually dry conditions over these months. This is a relatively new forecast metric that we have at the Bureau that you can see on our website. And so these extremes represent the top 20% of the historical range of rainfall for unusually wet conditions, and the bottom 20% on the right here of that historical range for unusually dry conditions. So in terms of unusually dry, we don't see a signal here for the east, but when it comes to unusually wet, we do see a signal. We're looking at about 3 to 4 times the normal likelihood of those unusually wet conditions. So what I showed before with that above median rainfall, that is translating to a higher likelihood of unusually wet or extreme rainfall type conditions. So we need to be aware of that. Okay, moving on to the temperature. So again, this is looking at the chance of unusually warm conditions now on the left and unusually cool conditions on the right. So again, corresponding to the forecast that we've been looking at, for these daytime temperatures, maximum temperatures, generally for the Gulf, we don't see much signal in terms of those unusual conditions, warm or cool. So we are looking at not a very high likelihood of those extreme conditions. But when we move into overnight temperatures, this is a different story. So if we look here, this really pops out of this now. Looking at the chance of unusually warm conditions, you can see there's a very high likelihood, more than 4 times the normal likelihood of unusually warm nights. So again, that's where this climate pattern at the moment is going to mostly influence temperatures, is looking to be those overnight temperatures with a high chance of warm or unusually warm nights. And I thought I'd show you this one as well. This is a fairly new product, again, that we have at the Bureau. You can look at this on our climate webpage. So that's bom.gov.au/climate. And this is now looking at the likelihood of what we call a rainfall burst event. So what this is an accumulation of rainfall over in a 3-day period for a particular threshold. So in this case, we're looking at the probability of 25 or at least 25 millimeters rainfall in 3 days in these different periods of interest. So this is a multi-week product. We don't go beyond weeks 3 and 4. So here on the left is week 2. So this is for the 24th to the 30th of October. Week 3 in the middle here. So 31st of October to the 6th of November. And then weeks 3 and 4 combined. So out to the 13th of November from the end of October. And so I just wanted to show you this because, again, you can see over the Gulf, we have an increased likelihood of burst events in each of these periods. So we're expecting that we may have some of these heavier accumulation rainfall events in these periods, at least out to the middle of November. And just looking at the streamflow outlook, so the streamflow outlook is showing that generally over the country, except for southwest WA, we're seeing high flows at the moment. So this is a combination of the above average soil moisture and the above average rainfall in the outlooks. So just reinforcing that flooding will be a key risk over the coming months. So these streamflow outlooks all showing us high flows for the next few months. Okay, now touching on the northern rainfall onset. So we define the onset of the northern rainfall season as the accumulation of 50 millimeters of rainfall from the 1st of September. So whenever that date first occurs, that's the date that we define as the onset of the northern rainfall season. And so that is now underway. We produce outlooks of this up until about the end of August. And so what we're actually seeing is the beginning of this season in some regions. So this plot here at the top is the northern rainfall totals from the 1st of September to the 18th of October. And everywhere that's green is where we have already had 50 millimeters of rainfall or more. So in other words, all of these regions in green show us where we have already had the onset to the northern rainfall season, and all the areas in these kind of orangey and yellow colors are where we have not had the official start of the season yet for northern rainfall. So for the Gulf here, for much of that region here, you can see that we haven't quite reached the onset date yet. But down the bottom left, this is showing what the onset date is for the areas that have accumulated 50 mils of rainfall. So those are shown in blue. And so you can see using this kind of legend down the bottom here, where we've had that onset begin in September and October so far. And the plot on the bottom right just shows us the number of days, well, in this case, earlier than the long-term average onset date. So it's showing all the green areas showing that we have had so far an early onset to the northern rainfall season over almost all these areas. And so that again is what we expect to happen when we have a La Nina event in particular. We do tend to see an earlier start to the wet season. All right, so I'll just move into severe weather to finish with. So I'll talk about the tropical cyclone risk and in particular its relationship with the El Nino Southern Oscillation. And then I will just touch on the bushfire outlook before finishing off. So this is the tropical cyclone numbers that have been ranked in terms of the number of tropical cyclones that have occurred for each year. So you can see how this graph is increasing, but each of the different years here is listed down the bottom. So from the year when we had the least number of tropical cyclones, that was 2015, right through to the year where we had the most tropical cyclone numbers, and that was 1973. And then they're color-coded according to whether it was an El Nino year or a La Nina year or a neutral year. So everything in blue are La Ninas, so strong La Ninas shown in dark blue, weak to moderate in blue. Sorry, a lighter blue. The grey is neutral, as I said, and then the red and the yellow represent El Nino years. And you can see here quite clearly that generally the higher number of tropical cyclones are associated with neutral into La Nina conditions. So really, we see kind of a clustering of La Nina years up the right side of this plot. So that again indicates that that we tend to have more tropical cyclones during La Nina, and also we tend to have an early start. So the first tropical cyclone of the season does tend to be earlier than average during La Nina years. So that's also something to be aware of going into the season. And this is just to highlight, so we're particularly interested in the eastern region here for the Gulf. So at the moment, so what we're seeing is a 74% chance of more tropical cyclones than normal in this region. And the average number is about 4 per year. So we are expecting, as I say, 74% chance of more than that number to occur this year, again, associated with the La Nina. So just to touch on the bushfire outlook. So what we've seen is, so we've had a lot of rain recently. This has led to a lot of grass growth. So there's still a risk of particularly grass fires in the coming months. But this has also meant that many of our forests are wet. So on balance, we are looking at normal bushfire risk, well, for Queensland as a whole. So certainly for the Gulf, as you can see. So there's no strong signal for an above average bushfire season for our regions here this year. So just to finally sum up, just kind of some of this key messaging. So if we look here at the Gulf and in Queensland more broadly, you can see the key risks, really the key hazards are tropical cyclones, So being a La Nina year, the tropical cyclone season, we tend to see more tropical cyclones, and that first one occurring earlier than normal. And we also expect to see higher likelihood of flooding associated with all that rainfall that we've been having over the last few years. Through the last 3 La Nina events, we have had wetter soils, and we're seeing an above average chance of high chance of above average rainfall, and so we are expecting a higher risk of flooding this year. So just to take home these points with you. So for the seasonal outlook side of things, so we're expecting a wetter and warmer Gulf region in the coming months, at least out to February, with an earlier than normal start to the northern wet season due to the active La Nina and negative IOD. And so above average rainfall, soil moisture and runoff levels are all very likely. And so then this is translating to an elevated risk of flooding, tropical cyclone activity, and an early first tropical cyclone for the season. So thanks very much for having me, and I look forward to any questions